Arithmetic series. Arithmetic series. What's a series? I mean, that's the biggest problem. When I say arithmetic, you might be like, okay, arithmetic, yeah? I hope you're like, I know basically what arithmetic is, but what does it mean when it says series instead of sequence? Is that the same thing?
No.
No, of course it's not. A series means we're adding up all those terms. So that's the only thing that's changed. And it's given away right underneath here, but I'll write it up here. Series means sum. Add up all the terms. Now, if your brain's right with me, if you're awake this morning, you're like, how are we going to add up all those terms? That's insane. Hi there.
Is Marley here?
Marley's here. Of course she is. Is it about her sweater? It's my fault. I didn't say anything to her.
That'll be wonderful.
And that's okay. Right now in the lesson, it's okay. I'm going to pick up right where I left off. It's okay to go, how are we going to add these all up? Are you out of your mind? No, I'm not. Coming up is one of the most astounding things we teach in math, and I'm not exaggerating. Not even a little. Anyways, we'll get to that in a second. An arithmetic series is the sum of the terms of an arithmetic sequence. So all our knowledge about arithmetic sequences will help here. We're going to take an arithmetic sequence, and we're going to add up all the terms. Well, it actually sounds easy. Can I just type them all in? You could, but that's going to take too long. If there was 50 terms, that's going to take you all day. We're going to find a much faster way. So we use the notation Sn, so that's going to be new. S for sum. Sum of n terms. Not just the terms, we're going to add them up to indicate the sum of the first n terms of a sequence. Now, if you're annoyed on a Thursday, they're like, oh, what is the, who cares? Why are we adding up all these numbers? It really matters in the next levels of math. It's like that, again, my daughter came home building factoring trees, and she's like, what are we doing here? I'm like, it matters. It matters to understand the makeup of numbers and how things factor. There's so much factoring coming. This matters. Okay. So here's what we'll write. Sn equals T1 plus T2 plus T3 plus ... plus Tn. If you haven't been keeping up with homework and you don't even know what any of those things mean, well, that's going to start to be a problem. Yes, because this chapter is like that. If you practice the stuff, it all seems pretty straightforward. If you don't practice it, it seems like I'm just making up, writing gibberish. Yeah? A deep historical legend. In fact, if you asked the top 5 math stories in history, this might make the list. Mostly true story. I put legend, but it's mostly a true story. You know, ancient stories they get a little flair to them. My mom used to do this to stories. She'd tell a story about something that happened at one of my hockey games or baseball games. And basically it'd be true, but she had souped it up a little bit for entertainment purposes. This one's souped up just a little bit. Here's the story. In the 1780s, a provincial German schoolmaster, you can imagine, a German schoolmaster, tough. And back then, you know, they didn't put up with anything. They weren't battling about phones. You sat still, you looked forward, you did your work. It was intense. Gave his class a tedious assignment of summing the first 100 integers. This is an old teacher trick. You don't see this much anymore. But in my classes, we'd have to write out lines. Yeah? I will not talk in class 100 times. It had 2 purposes. It was supposed to get you to stop talking in class. Did any of your teachers do stuff like this, make you write lines? It sort of fell out of fashion, but it was still around when I was in elementary school. Supposed to make you stop talking, but it was also supposed to keep you busy for a while. Some kids driving you nuts, so you give them some tedious thing to do, and then they just sit down and shut up for a little while. Yeah, it's good. That's what this math teacher was trying to do. Gave his class the tedious assignment of summing the first 100 integers. He wanted them to go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, all the way up to 100 and add those all up. Is it difficult to do that? No, but you'll be at it for a while. But one young pupil stood right up, walked up, and gave the answer, the correct answer of 5,050 in a very short period of time. His name, Carl Friedrich Gauss, again, who may be on the list of the greatest mathematicians of all time. And maybe you haven't heard of him, and that's because some of the stuff he did was foundational. That is, it set the stage for the great stuff that came later. See, by the 1780s, we weren't necessarily making too many breakthroughs. We didn't even know about atoms really yet. You know, we weren't on top of the world yet. But Gauss laid a lot of the foundation. Anyways, the smart aleck was Carl Friedrich Gauss, who would go on to join the short list of candidates to be the greatest mathematician ever. Gauss was not a calculating prodigy. He's not one of those people that you can just tell him some crazy multiplication question or addition question. He can just do it in his head. No, he was not that. He was just clever. And I'll show you how clever he was in just a minute. He had a deeper insight. Here's what he did. Hey, this is me typing this up. True mathematical awesomeness coming. Here's what Gauss did. He said, okay, I've got to find the sum of the first 100 numbers. So sum of 100, and he wrote them like this. 1 plus 2 plus 3 plus 4 plus 5 plus. And then he wrote a whole bunch of dots and then said, okay, and then the last three are 98 plus 99 plus 100. And here's where I'll add a little to the story and pretend I was there, which I wasn't in the 1780s, friends. But maybe he looked at that and went, no, I don't add this all up. I gotta go 1 plus 2 plus 3 plus 4 plus 5. Maybe he thought to himself, would it be faster if I added it the other way around? I mean, I got to do 1 to 100. Maybe it's faster to go the other way. I don't know if it is. Maybe I should go 100 plus 99 plus 98 plus 97 plus 96 plus 3 plus 2 plus 1. Maybe that'll be a little faster at least, or at least a little more exciting to start with 100 plus 99. And he stared at that for a couple of moments and went, wait a minute. I see it. Look at those first terms in each. 1 and 100. What's 1 plus 100? What's 2 and 99? 3 and 98. 4 and 97. That was his breakthrough. These all make 101s. He drew a line under them and said, let's add, hey, stop that. My pen's very particular. It likes to be straight up and down. Let's add them up. Let's add the two series together. So now I'll have two of them. There'll be two of those sums. Whatever answer I get, it's going to be double. But I know how to deal with double. That's not going to be a problem. Double's good. And he got, oh, when I add those, I get 101 plus 101 plus 101 plus 101 plus 101. The terms on the top are going up by 1 every time. The terms on the bottom are going down by 1 every time, so it's going to stay a consistent sum. Every one of these little sums is going to be 101. And I just wrote 100, even though that's 101. So he changed the job to add up all these 101s. Now here's where you come in, because you can help Gauss now a little bit. How many 101s is there? There's 100. Yeah? So he has 2 of his sums is 101 times 100. He was home free. He was already out of his desk, running to the front of the classroom to go, I did it, ha ha. Because 101 times 100, actually, you can do in your head pretty easily. Take a look at the answer. Multiplying by 100 is pretty straightforward stuff. Just add some zeros in there and then divide by the 2. 10,100 was double the correct answer, and so he had the sum as 5,050. Shocking. An unbelievable move, an unbelievable insight. And what we truly call beautiful mathematics. Beautiful mathematics is 2 things when it's beautiful. It's powerful, but it's also pretty easy. Yeah, we didn't do anything too crazy there. Adding up a bunch of terms, if they go up by the same amount, won't be too bad. As long as there's consistent, as long as there's a pattern there, we'll be okay. And I'll make a formula for it. Any questions about Gauss? Well, that example is not too bad. Do you need more time for that example? To build the formula we're going to do, reach down and get your seat belt from underneath your chair and do it up. Hold on, it's getting a little wild symbology. You don't really need to know what I'm about to do here. You should be able to follow it mostly, but you don't really need that. What you need is the formula at the end. Like, okay, so give me a formula. How does this work out in general? Not going up by ones like yours was, not starting at 1, any arithmetic series. So we'll use this same technique on the general arithmetic series to generate a formula for the sum. Here's us instead of Gauss. We'll want to go sum of n terms. We'll want to use anything for the first number. What symbol should we use for the first number in the sequence? A, that's what we've been using, okay? And then I'm going to use some brackets to try to help think, but I know it's going to get a little messy in your brain as I write these down. The next term in an arithmetic series, sequence, also series, but sequence, would be A, and then add on the common difference. So here's the next term, A plus D. That's how you get the next term. You take whatever your A is, and you add on the common difference. So I'm adding up all the terms. I got A and A plus D. Does anyone want to take a shot at the next one? If you've done enough of these, you're like, oh, I know what happens here now. The second term is A plus D. The third term, I've got to add another D. So I could write A plus D plus D. I could, and that would be right. Just in the interest of keeping this reasonably tidy, I'm going to write 2D. That's what that next term is. I'm going to do one more. If A plus 2D is the next term, what's the one after that? A plus 3D. There's a definite pattern here. This is difficult, what I'm going to do next. What's the final term? When I write it, hopefully you'll be like, oh, right. That would be the final term. The final term will be A plus n minus 1d. That's the formula for any term. So that last term is A plus n minus 1d. Now we're going to do what Gauss did. We're going to reverse that sum. That is, I'm just going to flip it around and go, okay, there's the last term. I'll write it first. And then I'm going to write this term last. It gets really confusing when I write the middle ones in. So I'm not going to write the middle ones in for just a second, okay? I'm just going to leave the middle ones out, and I will write them in just a second. But in the interest of keeping it clear for you the first time, I'm just going to write those first two terms, and leave all those middle ones out for just a second. I'm not pulling any trickery. I'm just trying to keep it reasonably clear. If I add, and I need a red pen here, if I add that term with that term, just like Gauss did, the first term with the last term, I get 2a plus n minus 1d. That's what I'll get for the first one. And I'll put a little square bracket around that. I know all these brackets and all these a's and d's make your brain sort of get fuzzy. And it's not because you're not smart enough. Please stop believing when that happens that you're not smart enough. It's because you're just not experienced enough. You haven't seen stuff like this enough times. As you see more of these type of developments, the brackets and the a's and the d's don't all run together in your brain quite so much. So don't give yourself a hard time. That's why we do stuff like this in math sometimes. This isn't on the test. Building this, it's not there. It's for you to walk through it once and go, ugh, I sort of got it, but not really. Then the next time it comes up, like something like this, you're like, oh, I sort of get it a little better. Look at this last term when you add them up. It's the same term. 2a plus, oh, I'm now figuring out what's happening over there. I got to stand straight up. Oops. And just like Gauss, we'll get that same thing every time. Every term you add comes out to 2a plus n minus 1d. Now, if you're annoyed that I didn't write all the other terms, it's because they get a little awkward looking. This one is one less than that, so it would be a plus n minus 2d. And that's awkward to look at. And to add those two together, you do get 2a. You've added an extra d, so it's n minus 1. But I don't want to get sidetracked by that. I want to just try to convince you that all of these terms end up being the same, just like they did for Gauss. And they do. The first sequence is going up by d. The second sequence is going down by d. So those things all just cancel out very nicely. So what I get is 2 of those sequences is every single term is 2a plus n minus 1d. How many of them is there? In Gauss's example, I told you it was 100. How many are on this list? Oh yeah, you can just see the ones I've got there, but we don't know how many there is. N. There's n of them. You're like, what's n? I'm like, I don't know. The question's going to tell you. If the question says add up 50 terms, n's going to be 50. If it says add up 30 terms, n's going to be 30. And so one more step later, I've got my formula. Now listen, friends. If you've been keeping up with homework and you're good at subbing into formulas now, you know, if I sub in the a's and d's over here, I get the answer. Or if I put the sum over there, I can isolate over here. If you've been doing that, you're ready to go home. You're like, okay, see you, Miss Todd. Have a great day. That's the formula for adding them up. So I just plug the a and d and n in this one. It's just a slightly different setup. It's actually very similar looking to the sequence formula. If you haven't been keeping up with that, there's good news in this chapter. If you just get into it, try a few. There's just different formulas for different situations, but they basically work the same. You sub the n's and a's and d's over here, and you get your answer over there. I do not expect that that slide should be like perfect. I totally get all those steps. I understand the symbols all run together. Here's what we really need out of all that. And I've seen it taught that way before, where teachers just walk up and go, here, there's the new formula. That's how it works. Trust me. I'm not making it up. Go ahead and use it. But I wanted you to see where that came from. Any questions there, though? There's an alternate version, and it's a very powerful version. You might like the other version depending on what they give you. We can rearrange that formula slightly. That formula says, that formula says, oops, n over 2, 2a plus n minus 1d. That's what that formula says. But I can just do one little tiny rearrangement and change this to n over 2 and just break it into a and a. Now I need somebody who has been doing enough homework that they recognize part of that. This part. Oops. What's that? That is the formula for any term, right there, sitting inside there. So here is a formula you might like better. You're welcome to like it better. What I need to warn you about is it just depends on the information given. And I'm going to write a little box here, summarizing both. The first one was n over 2, 2a plus n minus 1d. That's a formula to do sum. And here's another formula to do sum. And you might love the second one a lot better, which I do too. But here, you need the last term. And lots of questions don't give you that last term. They only give you A and D. So that's the difference between the formulas. If you've got A and D, use the first one. If you've got the last term, boom, you're going to love the second one. It's just a matter of what you need to plug in there. Incidentally, if you're taking physics next semester, or if you took physics this semester, this is the game of physics a lot of times. Which formula do I use based on what information do I have? Once you get used to that, physics becomes a lot easier in a hurry, where it's just like, okay, look at my list of formulas. What do I have? Which formula might be able to help me here? And that's true here as well. Well, it actually is possible to sleep through most of that and just tune in for this and go, okay, how do I find the sum? And the answer is you plug into one of these two formulas, and that'll get you the sum. Loses all the fun out of it, but it accomplishes what you need. Do you need more time there? I think it says page 5 of 7. Is it just 2 examples and I'm done? No, 3 examples. 2 on the first page, 1 on the last. Boom, done. Yeah? Using these is no harder than using the other formulas we've been using. It says find the sum of the first 40 terms of the following. Only one decision to make. Can I get A and D, or do I have the last term? In this one here, do I have the last term? No, so you're going to want the first formula. Somebody really clever goes, well, I could use the other formula and I could find the last term, couldn't I? Yes, totally works. Probably more steps than you want. It's probably easier just so you go ahead and use the formula, the first formula. So I'm going to write down that formula. Sn equals n over 2, 2a plus n minus 1d. Good. I like going over to the side, especially physics people. You go over here and go, oh, what do I have? Do I have the a? I really need the n, the a, and the d. I don't know if this is the way to actually do them in your homework. This is me teaching going, here's my thought bubble over here going, if I'm going to use this formula, I need n, a, and d. If I have n, a, and d, plugging into this formula is really not a big problem. What's n? How many terms am I supposed to add up? 40. Well, okay, finding n is often pretty straightforward. Most of the time, they just tell you how many terms they want. Most of the time. There is that one question out there where they give you the last term. You got to work it backwards, okay? A. Okay, well, that's supposed to be the easy one. What's the a here? 3, that's the first term. And then the d is 8. How do I get that? 11 minus 3. Oh, but what if it's a geometric? How I know if it's arithmetic or geometric? You're supposed to be able to recognize that by this point. You're supposed to be able to look at them and go, oh, this is arithmetic, this is geometric. Just by doing a little calculation in your head, which is this? Is it arithmetic, geometric? If it's neither, it's not our problem. We'll do it in other courses. Well, now it's just sub in. Sum of 40 terms is 40 divided by 2, 2 times 3, plus 40 minus 1, times the d, which is 8. I'm going to try and do it in my head, just to try and stay young. Too late, Mr. Todd. I'll do the joke for you, so you don't have to feel bad. But for you, you're just going to do it in your calculator, right? Here we go. 39 times 8. 312. 317 times 20. 6340. Don't tell me if it's wrong yet. I'm going to check it. Stop yelling at me. 39 times 8 is 240. It's 312. Plus 6 is 318. Times 20. 6360?
Yeah.
I don't know why I got 4 there the first time, because I totally got 6 the second time. Is it right? Yeah, but you're going to pump in your calculator, you know, like. I'm just trying to avoid getting mentally old. Let's not wait around until tonight to find out you don't know how to do these. Take a moment and see how far you can get in the second one. I'll do it. I'm going to do it very slowly. So if you're like, I'm totally lost, you can just copy along with me. But if you're like, no, I can do some of this. I can write down some of these things. I can write down the formula. I think I can figure out N, A, and D. I can start it. Try it out. See what happens. And then we'll do the last one together.
Wait, are we doing B?
B. I'm going to do it for you. I'm not trying to get out of work. I just like, let's try one to find out where we're at with this, because this question really is the same except for one little tiny thing. Kyle, did you have a question?
I was wondering, because I thought I found a way to do that one, but I don't know.
What do you mean?
Well, because the question you're doing right now,
Yeah?
I was wondering if you could find because like, you can see what it goes up by.
Yes.
Pretty easily, like, see what it starts with.
Yes.
Because you just keep minusing until you get to like, whatever, in front of 0.
Mm-hmm.
And then, can't you just minus the A off any of those numbers, and then just like do the square root thingy, and then it's like 6. What am I saying? Never mind.
I don't know. Write it down. Try it. It could be. You're onto something. You could be. If you are trying it on your own, you can be looking up every once in a while, seeing if you're doing okay, so you can feel good about it. Especially the D. You might want to check the D. Your brain might tell you a D is exactly opposite what it needs to be.
Is that the start of it?
A is 57, but it's going down by 6.
I thought I was giving you like the last 4 digits kind of thing.
I've run it all plugged in now, so you can check your plugging in. And then I'll take an extra couple of minutes to do this one in my head, because I think it's got some special challenges to it. Woo! I'm going to check it, so don't yell at me if I don't got it right yet. Not 57 minus 1. Oh, good. I was so excited about multiplying by 57.
40?
Yeah, it's 40. Thank you. Got distracted there. 40 minus 1. Oh, that's even easier. Is it 39? No, it's not. Negative 224. Negative 110. 220. 220. Another 0? Nope. Negative 224. 14. $234. Jeez.
Nope.
Negative 234 and 114. Negative 220. No, still not right. What is it, Nathan?
2400.
What's that?
2400.
Negative 2400? Let me do it again to figure out what I did wrong now. 39 times 6 is 230, negative 234, plus 114. 120. Oh, I did 220. Okay. I'm working on it.
Just a little bit.
Just a little bit old, is that what it is? Questions? If you've been keeping up, you're unimpressed maybe. You're like, okay, so I just sub into this one now? It just means sum instead? It's really not much different than subbing into the previous equation. Last one, find the sum of these numbers. 4, 15, 26, 213. How many terms is there? We don't know. Yeah, no, that's a problem. That's the one I was just talking about a minute ago. First, I need to know, what term is this? So this question has two phases. First, from previous homework, go back to this and go, okay, Tn equals a plus n minus 1 d. Let's find out what term number that last thing is. Cruel that they gave us that without telling us. What do we know? Tn is 213. A is 4. D is 11. That's a question that was in the homework a bunch of times. Subbing that in to find the term number first. That's why that question was in there, to get ready for this. So if I sub that in, I get 213 equals 4 plus n minus 1 times 11. Now, there's lots of options on how to solve this. If you like to distribute the brackets first and then solve, I like that too. I'm going to do it slightly different just to provide you options. I'm going to go, okay, 213 minus 4 equals 11 times n minus 1. And so I get 209 equals 11 times n minus 1. Divide that 209 by 11, which is 1, 9. And so I get 19 plus 1 equals n. If that's just flying past you and you're like, I don't know how to do any of that. It's not time to panic for this test, but it's time to get in this. That's straight out of other homework. It's just finding the term number. So it's time to roll. Now I can switch over and go, Sn equals, which formula?
Oh, the second one.
The second one. The first one would work. You can use the first one, but just in the interest of trying out the second one, the second one says, just do that. So the sum of 20 terms is 20 over 2. Take the first term and add the last term. This one is very close to what Gauss was doing. Let me just write it a different way and go, this is Gauss right here. Add the first and last term together. Multiply by how many terms? And divide by 2. So that's Gauss right there. That formula I maybe could have just thought out from Gauss. Did I get that one right, Nathan?
Yeah.
It's not over yet, I guess. Well, friends, if you're a late bloomer in chapters where you like to take the first couple days and just rest and then do a mad scramble at the end of the chapter, I think you better start today. I think so. That's my judgment of the situation. Because when's your test? I've forgotten already. On the 17th? But you only get one review day. So you can't be playing around and catching up on the chapter on the review day. That's not going to work out.